chapter 6 about the quadratic functions. Right, so let's get to the lecture first. I'm going to give you some brief introduction about quadratic functions. All right, so let's start with some introduction about the quadratic function in its graph. So let me just put the main section. So the typical quadratic function look like this. So we got f of x in chapter 6 of the quadratic.
Hello, Professor.
Yes. Yeah.
So one of our classmates, Hing Ta, he said he will be late because he has academic advisement. He will join after the meeting.
Okay. Thanks for letting me know. Yeah, that's fine. I understand.
Yes. Okay.
Right. Okay. So all right. So the quadratic functions, and let's start with this is a function, right? So we use a function notation f of x equal ax squared plus bx adding c. And here a cannot be 0. If a is 0, then we do not have a quadratic function anymore, right? Then we end up with a linear function. That's not what we want, right? We want a quadratic function, meaning the leading power must be 2, right? That's 3 aspects. And typically, a quadratic function, when you graph it, right, you're gonna see a parabola. And we just draw a random parabola, and this is called parabola. This parabola is opens upward, right? It opens upward in this case, and then all the parabola has a vertex. And in this case, the lowest point, what we call vertex. And then I'm going to show you another type, right? We have two major type, right? So the other type is this. So it opens downward, and the vertex becomes the absolute maximum. So this is the vertex. It's spelled here, so let me just correct it. Vertex. So this is the minimum, absolute minimum, and this one is absolute maximum. Based on the shape of the graph, it will look slightly different, right? Also, we have another thing, it's called the axis of symmetry. Right here in the middle, this is called axis of symmetry. The same thing here, right? For this line separates the graph into half and half, and they form a mirror image. They form a mirror image. If you, let's say, fold it, if it's on a paper, then you draw it and fold it, then they will form a mirror image based on the axis of symmetry. So this is the most important thing about symmetry line, right? Symmetry line give us a perfect mirror image in this case. And also, so basically the point on the left hand side, let's say pick a point here, that's a symmetry point on the right hand side, right? If you pick a point here, that's a symmetry line on the right hand side. Pick a point here, that's a symmetry point. So very, very similar here. If you pick a point here, that's a symmetry point on the right hand side. Pick a point here, symmetry point. Pick a point here, symmetry point. And that's basically most important thing about the parabola, right? And this shape is called parabola. And that's what the graph look like. And then now let's work on the function itself. Let's learn how to complete the square. And then let's analyze the function itself to figure out where is the vertex. So we're going to determine the vertex. And axis of symmetry. From the function itself. Right? So let's start with the function f of x. So it draw the function f of x. Let's start with the general form. Later, we're going to look at some of the examples and learn how to complete a square. And the method we are using is called completing a square. Complete the square. Yeah. So that's hop on it, right? So let's look at how to do that. So first of all, you will pick the first two terms, and then basically just factor out the a. Now inside of parentheses, and the form parentheses, and then we get x squared plus b over a x. Now I'm gonna leave some space here at the c. So now we're gonna need a third term because it's a square, right? We need a perfect square. So besides these two terms, we need one more term to get a perfect square. And this term will be you taking the middle coefficient here and multiply that by very important, right? Half times. Take the half of the middle coefficient, b over a. Now we're gonna end up with a b over 2a. So this is step number one, right? Use half of the middle, of the coefficient in front of x. The coefficient in front of the x before x. Okay, now we get the b over 2a. And second, square the result and square b over 2a. And square the result from step one. And that means we just square b over 2a. Basically, we adding a term right there. So we adding b over 2a square. And because we have a function, right? We add a term, we have to subtract it. We're gonna subtract the same term. All right, so this is the key thing, right? We add a term, we subtract a term. If you cancel that, nothing happens. However, we want to keep the three terms right here. These three terms is what we need. And then we're gonna distribute this, move this outside. Okay, so let's keep going. So now a stays in the front, right? X squared plus b over a x plus b over 2a parentheses square. Okay. Then we're gonna distribute this, move the outside. So it will be plus c minus a times that is minus, right? So a times yes, it will be b squared. Now we're gonna expand it. B squared will get 4a squared on bottom. Okay. Now on the other part, right, we can simplify. So basically, and this is the perfect square we need. And you can also just factor this, right? Like this, like what we did for the trinomials. We do the same thing, b over 2a and b over 2a. Intercept equation. B over 2a here. Yeah. And then they go plus. And this is how when you add them, you get a middle term here. So so basically we have a perfect square, right? So it's a times x plus B over 2a squared. And on the outside, so c minus, and then a get canceled, right? Drop the power exponent here, so we get b squared over 4a. Now, basically, once we get to this point, then the axis symmetry occurs, right? Axis symmetry comes from this. Come from this equation here. So you set it x plus b over 2a equals 0, we get axis symmetry. So that will be x equal to, we subtract b over 2a from both sides equation minus b over 2a. And then the vertex, right? When you see this is a perfect square right here. So this is always going to be greater equal to 0, this part, right? We have a, yeah, so this could be, this part is always greater or equal than 0. It depends on the a. However, it's never going to be 0. So this one could be either the minimum or maximum here, this part. So if a is greater than 0, then it's the minimum. If a is less than 0, then this is the maximum. So the vertex, it's going to be minus b over 2a. You want to make sure this is 0, right? This part is 0, so it has no effect on the outside. And then the y value will be c minus b squared over 4. Yeah. All right. So this is basically how we generate the axis symmetry and the vertex from the given function. Do you guys have any question about this? Okay, no question, right? Very good. So now let's take a look at one of the example. Let's say I'm gonna make it very simple, right? Let's say we get a function f of x equal x squared plus 4x minus 3, something like that, right? So we get a function here. So let's find the axis symmetry and also the vertex. Now with the concrete number, it's actually a lot easier. So first of all, you take in the first two terms, right? Put in the parentheses. There's no coefficient here, so we're gonna keep as x squared plus 4x. Now step 1, you take half of the 4. You do half times 4, you get 2, right? Second step, square that, 2 squared. You get 4 as well. So we get adding 4 minus 4, right? And then minus 3. Now we're gonna keep those 3 terms here, right? And move this outside. So we get x squared plus 4x added 4, then we get a minus 3 minus 4. Okay. Now we get x plus 2 squared. This is perfect square minus 7. Now if you want to find out the axis symmetry, and you add in x plus 2, set this equal to 0, solve x, so minus 2 minus 2, x equal to -2. Right, so that's the axis symmetry and vertex. And when x equal -2, you plug it here, right? -2 adding 2 square, that's a 0 square minus 7, so minus 7. And because here a is greater than 0, right? In this case, since a is greater than 0, meaning a is positive. In this case, a is 1, right? I mean, that's the invisible 1. 1 is greater than 0, then it opens upward, right? Then we have a minimum here. So this vertex actually is minimum. Yeah, so you can draw something like this, right? Draw a parabola and then try to visualize this. When a is greater than 0, it opens upward. So that's why we get a minimum down below here. Okay. Any question about this? Okay. Let's take a look at another example. Right? So I'm gonna just quickly make up another one. Say f of x equal to now this minus 2x squared or something like that, and minus, we already have minus, so let's do plus, right? Plus something like ax, and adding 7 in the back, right? Something like this. So here we know that a is less than 0. This is a, right? Less than 0. That means this parabola is totally downward. So we do have a maximum here. So again, we're going to determine the axis of symmetry and then the vertex. So we complete the square. Take the first two terms, factor out the -2, and we get x squared minus 4x, right, and add itself the back. So leave some space inside the parentheses. So now we take the middle coefficient, right, and then half of it. Take half of the middle number, and you're going to end up with a -2. And we square that. Square the -2, we get 4. That means we're going to add 4. That's the By doing that, we actually, if you subtract, you cancel them, then you go back to the original function, right? Nothing changes. But we want to do some algebraic manipulation or algebraic transformation to turn into a standard form. To turn into the standard, form, we can extract the vertex and also axis of symmetry from the function itself. So now again, we keep the first three terms and move this outside. So -2, x squared minus 4x and 4. Now slowly move it outside, you're gonna get 7, adding 7, adding 8, adding 15. So now we almost add -2, and this is a perfect square. It will be this, right? -2, -2, both negative. Must be negative, so it's that turned into a perfect square, x minus 2 squared, and adding 15. Then right here, axis of symmetry come from this. So symmetry line, it's gonna be 7x minus 2 equals 0. So x equal to 2. That's axis of symmetry. And then the vertex, when x equal to 2, and the y value, that is, you see, putting the 2 here, you get the 2 minus 2, 0 square times -2, that's 0, right? This whole thing becomes 0. And adding 15, that's 15. Always, right? When you plug in the axis of symmetry into this number into the equation, this whole thing will become 0. This right here. And then we end up with the only number in the back, which is 15. So you get vertex as a symmetry. Any question about this? Okay, very good. So I guess
How you got 7 plus 8 on the second step?
How do we get that, right?
Yes.
Why is it 7 plus 8? Okay, very good question. So you see, when you multiply -2 by -4, you get +8. Now basically you're moving this term outside. You see -2 times -4, you get +8. Right? So you only keep the 3 terms right here, only these 3 terms inside, and then the extra term you're gonna move it outside, right here. These are 3 terms you keep inside of the parentheses. And then the very last term here, you multiply that, -2 times -4, give us +8. Then
Okay, I understand, but why you moving the -4 and multiply to 2 and you moving to outside of this?
because only these three terms is what we need to get a perfect square.
Oh, okay, I see.
If you have this extra term, extra number here, then you wouldn't be able to get this perfect square. Make sense?
Yes, thank you.
Okay, very good. Yeah, so this,
Can you explain how to get the vertex again, please?
4 again, sure. So
How to find the vertex?
how to get a 4, right? How to get this 4 and this 4, right? So first of all, you're taking the number in front of the x, right? You do half of it, or divide that number by 2, right? Whichever you feel like to do. You can just divide this number by 2, -4, right? By 2, you get -2. And then after that, you square the -2, you get 4. So step 1,
Okay, I got it.
yeah,
Yeah,
divide
but how about finding the vertex?
the vertex. Okay, the vertex. So
Yes.
mhm. So first of all, we're gonna find the axis of symmetry by setting this one equal to 0, right? Then we solve for x. So you're adding 2 here, adding 2 here. We end up with the x equal to 2. And once you determine the vertex, then now you plug in this number into this. You plug the number f2 into this. So you're gonna do -2 times 2 minus 2, x becomes 2. And 2 squared, adding 15. And this 2 minus 2 squared, 2 minus 2 is 0, right? So you get -2 times 0 squared, adding 15. 0 squared is 0, right? -2 times 0 is 0. So 0 plus 15, that is 15. That's how you get the vertex. In this case, because it's concave.
Okay, I got it.
Yeah, you got it? Okay. And this vertex is 215.
Thank you.
No problem. And then this is what we call the maximum, right? Because it's an open downward, so this is definitely the highest point.
Yes.
That's why it's a maximum. Okay. I'll let you guys do some practice. I know this is not an easy topic today. So we're gonna go back to the web work. And let's start with the completing the square. That's very, very important to meet. So we talk about a quadratic formula later, but we do it the same thing. I'm gonna show you in a bit. Okay. But let's get to the exercise first and get some practice. Okay, so we are chapter 6.1, right? It's about completing a square. All right, so I'll actually try a couple of them. Okay, so solve the quadratic equations. And yes, let's start with this. Okay, I'm going to show you a couple of them before we do the completing a square. Okay, so doing the screen first. Okay, so right here, right, we get a on the left hand side the perfect square. So yeah, okay, here we go. So on the left hand side, it's a perfect square. So you do this, right? X, break down that at the center and at the center. We're gonna get a perfect square, which is this becomes x minus 7 squared equal to 8. Now from here we get a something square equal to a number. So we're gonna take in the square root from both sides of the equation, right? We're gonna do square root x minus 7 squared. And on the right hand side, when you take the square root, you're gonna put plus minus because we do have two solutions here for the square root. Yeah, are you guys following so far? Did I lose anyone?
No.
No, okay, very good. Now square root offset each other. Okay, x minus 7 equals to plus minus. And we can simplify this to 4 times 2. And then this is x minus 7 equal to plus minus 2 radical 2. Now from there, just add 7, right, from both sides of the equation. Then we're going to end up with the result. Yep, S7. And so that we end up with x equal to 7 plus minus 2 radical 2. So basically for the quadratic equation, usually you have two solutions, right? There are three possibilities. The two solutions, you're going to see that could be one solution. If it is something like x squared minus 14x, right? That is 45. Equals 0, then there's only one solution. Solution 7. Because of 0 here. And sometimes they, so this is second case will be one solution. Two repeated solution, we count it as one solution. And third case is a 0 solution. Remember, we're going to talk about quadratic formula in a second. So basically, that's our approach. Now, in this case, will be this is the answer: 7 plus minus 2 radical 2. Okay, so let's go back. So putting 7 plus minus. Or list it. Okay, so we will do plus first. 2 radical 2. And then the other one will be 7 minus 2 radical 2. Yep, so now we can check the answer. Yeah, they're both good, right? So I'll let you guys try one. Okay, you guys try this one. All right, guys, and let's go over the solution. So first of all, we put the square on the it's a perfect square to x -5 -5. So that becomes a perfect square. It's x minus 5 squared equal 27. And again, you're taking the square root from both sides of the equation. And you put plus minus, right? Always you take the square root, we have two solutions for the even root. So squares and square root cancel each other, and we end up with x minus 5 on the left. On the right, we will simplify. 9 times 3, x square root of 9 is 3, so x minus 5 equal to plus minus 3 radical 3. And if you add 5 on both sides of the equation, x equal to 5 plus minus 3 radical 3. So two solutions, x equal to 5 plus 3 radical 3, x equal to 5 minus 3 radical 3. So if you go back here, let's see, 5 plus 3 radical 3, 5 minus 3 radical 3. Check all the answers. They go good. Okay. Any questions?
No.
Okay. No, very good. Yeah. And let's look at this one. Okay. What do you think of any suggestion about this one? Okay. If you complete the square on the left, right? This one right here, over the x, 81, 81. Right, this is a perfect square. So it's x minus 1 squared equal to minus 125. Is that even possible? A number squared is never going to be negative, right? In this case, no solution. If you can also solve it, right? Like x minus 1 squared equal minus 125. You can take the square root, minus 1, and then plus minus square root of minus 125. But this is not allowed, right? A negative number under square root, this is not allowed. That means, again, no solutions. So it's a perfect square. A perfect square cannot be negative, right? It's non-negative. So a perfect square is non-negative. Let's quickly make a note. A perfect square cannot be negative. It's either going to be 0 or positive, right? It's non-negative, or you can say non-negative. Any question about this? In this case, there's no solution. So we're just gonna solve linear solutions. Oh, they okay, I see. So no real solution, but that's a complex solution. Okay, so we still gotta solve it though. We're gonna solve it using complex, no real solution, right? I misinterpreted this question here, so let's just solve it using a complex solution. So right here, no, not allowed under the real number, right? But we learn a complex number, so we do have a solution here with a yeah. So what I talk about here is it's all okay, right? We're talking about real number and then complex number. Although in a real number, no solution, right? You see that, but in a complex number, it's a solution. So that's all for the complex solution here. We last time, right? Last week we learned about the complex numbers. We're going to use it here to get a complex solution. So step one, just like the other one, so x minus 1 squared. And we're going to it's right now. After that, taking the square root, x minus 1 squared equal plus minus radical 125, minus 125. And we know that minus 125 equals 125 times negative 1. Negative 1 is I squared. So this actually becomes minus 1 equal plus minus 125 I squared. Right, so that means we will end up with a couple of complex solutions. And then break down to 125, 25 times 5, and then I squared, right? Then simplify with x minus 1 equal plus minus square root of 25 of 5, square root of 5 times I. Now from there, you just add 1 right? From both sides of the equation. End up with x equal to 1 plus minus 5 radical 5i. Right, so this part is true only for the real number, but we have complex numbers, and no real solution. But a complex, couple complex solutions, 1 plus minus 5 radical 5. Any question about this? 1 plus 5, so 5i. First solution, second solution will be 1 minus 5 square root of 5 i. Okay, now check the answers. Yeah, they were good, right? See, complex solutions. Okay, and then you guys try one of this. Maybe you show me another. Okay, so let's see. Okay, now you guys try to get a couple of complex solutions here. Okay, let's go over the solution one more time. Left-hand side becomes minus 2 squared. Right-hand side minus 27. Now take the square root from both sides of the equation. Equal to plus minus square root minus 27. Then this becomes x minus 2 plus minus 27 times I squared. Then from here, break down 27 as 9 times 3. So plus minus 9 times 3 I squared. Then we apply. Yeah, so we get a plus minus 3, radical 3. Then we have 2 from both sides of the equation. Cancel the 2, x is by itself. So end up with the final solution here, x equal to 2 plus minus 3 radical 3r. And typically you can split it as 2 solutions, right? 2 of them, x equal to 2 plus 3 radical 3i. X equal to 2 minus 3 radical 3i. So that's the answer. Any question? 2 plus 3 radical 3i. The other one is 2 minus 3 radical 3i. Okay, so that's a complex solution. Oh, let's go back. Yeah, that's the correct answer. And let's look at next part. Yeah, so start completing the square, right? So yeah, so let's review this one more time before you guys start practicing. Share screen. Okay, so first of all, as a typical question about completing the square, so we need to in the box, right? So first of all, take the middle number. So easiest thing to do is step 1, take you can skip the sign even, right? Just take 22 divided by 2, you get 11, right? The number here, number in front of that, just the number itself. Second step, square it. So you get 121. Are you? Yeah, 121. Divide. Step 1, divide the number in front of x by 2. Second step, square the numbers of the result from step 1. That's basically how you would complete a square. So right here, you're taking 22, right? Divide by 2. 11 square that, you get 121. And you add 121, you subtract 121. So eventually we're gonna end up with so right here, just put it underneath. That will be x minus 11 squared minus 121. So the number you're going to put in the box will be 11, right? Here will be 121. Right, and then minus 11. Okay, so okay, so it's 121 and 11 squared. I think here I should just this, just do. I don't think I need this. We don't need this, right? You just want, they just want us to figure out what that number is. So we don't need to subtract 121 yet. They just want us to complete the square to come up with the third number and then complete the square. Oh, you guys have one of this. Okay. No, same question. No, another one. Oh, still same question. Yeah, you try this one. All right, so the number you're gonna need is 100, right? So you do 20 by 2, you get 10 first. Now second step, square root of 10. So that's gonna be 100. So put 100 here, and this is x minus 10 squared. Any question about this? So the number we need, 100, x minus 10 squared. That's a perfect square. So you can check it. It's good. Okay. Yep, so I think we can skip this. Yeah, let's try one of these, right? Sometimes the number may not be well rounded. So let's look at what if number is not well rounded. Like this, we cannot evenly divide it. We treat it same way, right? So first of all, you divide 9 by 2. Okay, step 1. Divide 9 by 2, which is 4.5. And then second step, we square 4.5. I'm gonna show you a trick how to get this number really quickly, right? When you have this type of number, like 4.5, 3.5, anything with a 0.5, right? You're gonna do this. 4 multiplied by the next number, 5, get 20. Then put a decimal number, and then 5 squared 25. Right? So you do this number, whole number 4, multiplied by next number, 5, get 20, that's our whole number and then put a decimal, carry over the decimal. 5 squared give us 25, so it's 20.25. Same thing, like what if you have a 6.5 square? We're gonna do 6 times 7, 42. Bring over the decimal, 5 squared, 25. That always works, right? So the number we're gonna put it in is 20.25. It's a little number trick. I learned it. So I just want to show it to you guys, so you guys can also use it. But definitely you can multiply using the long multiplication, right? Not a problem. You get the same thing. So this is one. So the answer will be 20.25, and then inside of the parentheses will be x plus 4.5. Okay, so it will be 20.25 and 4.5. Check the answers. What? Incorrect. To complete a square, only enter fraction, not decimal numbers. Okay, that means you gotta do 20 and a quarter, right? No, that's not. So it will be yeah, they want to. So it's 81/4, right? And yeah, I'll show you. I'll show you in a second. No worries. I'll show you how to leave as a fraction since they don't want to decimal numbers. Too. Yep, that should be good. They just want to. It's the exact same number, right? But they don't want to decimal numbers. I feel like decimal number is easier. So in that case, we cannot divide it. So we can leave it as a fraction and just square the fractions. That's all. So we're gonna go back here to revise it. So 9/2, right? Because now the 2 and then square that. Now the 2 square. It's 81/4. That means 81/4. That's what we need here. And then that inside that we'll just take in this term 9/2. Well, because it's perfect square. So that's how we end up with the answer with the fraction again. Any question? Okay, you guys try one of this. Right? Another. Nope. Yeah, try this one. All right, let's go over the solution. Step one, you take the middle number 7 by 2. Step 2, square it. So when you expand it, 7 squared is 49. 2 squared, that's 4. Right, so it's 49 over 4. The first box. Second box, you use the number inside the parentheses, 7 over 2. And that's how you complete a square here. 49 over 4. And then 7 over 2. Okay, check it. You just want a fraction answers. No decimals allowed. Yeah, so this one, it's basically completing it step by step, right? I guess let's you guys try it first. And another, let's try this, right? Let's try first. Just follow the method I showed you earlier, step by step.
Hello, I cannot hear you. I think you mute your mic.
So I did, I mean my mind, yes. So I'll explain from the beginning. So first of all, we square we take the half of 10, get 5, and then we square the 5, we get 25. And go back here, so we add 25 and subtract 25. However, we're only going to keep those 3 terms on the left, which is the perfect square. So adding 25 from both sides of the equation, so we end up with cancel that. So we get 37 on the right hand side. On the left hand side, it will be a perfect square. This is a perfect square. X plus 5 squared equals 37. Now we're taking the square root from both sides of the equation, and then we get x plus 5 equal to square root, cancel each other, plus minus radical 37. Now subtract 5 from this equation, cancel that, equal to 2 minus 5, plus minus radical 37. Then if you want to rewrite it, you can write it as x equal to and 5 plus radical 37 is equal to minus 5 minus radical 37. Any question about this? Okay, step by step. So that's going to be at a constant to complete the square. And we write it as a square. Okay. So you're going to do adding 25, right? Like what we did earlier. And on the right hand side, 37. And this is x plus 5 perfect square. Let's break so we radical 37. And then eventually find a solution. These are solutions. So minus 5, adding square root 37, comma, minus 5, minus square root 37. Yep, that's pretty much it. Okay. So yeah, so it's all good. All numbers are good. Okay. All right, so let's move on to next slide. See setup. Okay. Separate the again, first slide, we're gonna move this 75, right, to the right hand side. So you're gonna get 75 here. And the rest of them will be similar, right? So I'll like to try this one. One more time. Now let's finish the problem really quickly. So step one, you take the 16, divide by 2, you get 8. Second step is square that, you get 64. So on the left, we're going to get x squared minus 16x, adding 64, right? You can also do the same thing on the right. Because we add 64, you can add 64 here as well. Then we keep the balance, right? We're adding the same number on both sides of the equation. That works. And now this is a perfect square, x minus a squared. On the right, when you sum up those two, you get 139. Now next step, we're taking the square root on both sides of the equation. Under 39, let's see. Looks like we can simplify that. 49 times 3. No, yeah. 13, no. So it's x minus 8 plus minus radical 139. Then add 8 on both sides of the equation. And get x equal to 8 plus minus radical 139. So you get two solutions equal to a plus square root of 139. And then x second value, x1, x2, right? It's x and then a minus radical 139. Any question about this? So that would be 64, right? And on the right hand side, 139. We can actually check it first before we move on. Yeah, it's all good, right? Now we can move on, x minus a squared. Okay. And we split the x square root of 139 on the right. And find the solution, 8 plus square root of 139. Then a minus 139, square root of 139. Then let's click the answer. Yeah, they go good. Any question about this? Okay, this is similar one, but this one has, let me see, right? Let me see if I put in the. Okay, so let's see, that'll be 4.520. See if they take this answer. So, that'll be 38. If so, I'll actually practice this. Yeah, it's okay. This one decimal answer works. So, I'll actually try one of this. That's a lot of decimal numbers. So you can work with the decimal numbers, right? If you don't like the fractions, but you should know how to do both though. You gotta be flexible in terms of solving the problem. I'll try this one really quickly. Then let's go over the solution. Step one, you move this 75 to the right hand side. Okay, 75. Now step you take the 5 by 2, you get 2.5. If you want to leave it as a fraction, that's totally fine. Your decimal is just slightly easier. Okay, so definitely we square the 2.5. Again, it will be 2 times 3 is 6. Error of the decimal point, 5 squared 25. So 6.25. That's the number we need to complete the square. On the right hand side will be 25. That's 81.25. So this is x minus 2.5 squared. Yes, on the right hand side will be 81.25. Now we're gonna take in the square root of both sides of the equation. Actually, you know what? I think it's better we keep as a fraction because we'll be able to simplify later. So yeah, so let's work with the fractions. So we keep as is 5/2. Now we're gonna square that, right? To get a number. So we square that 5/2 square. Get 25/4. The number we are using 25/4. So on the right hand side, we're gonna add the 25/4. And 75 is gonna write it as 75/1. Adding 25/4. And the LCD is 4. So multiply both top and bottom by 4, you get the 75/4 by 4. That's going to be 300/4 adding 25/4. That's going to be 325/4. So this is 5/2 square, and now we get 325/4 on the right hand side. Then we take in the square root, x minus 5/2 square, and then taking the square root outside on the right hand side plus minus square root of 325/4. Okay. Now next step. Oh, the square root cancel each other, so x minus 5/2 equal to and then we can simplify this because 25 going to 325. That's why I decided to go with the fractions because we can simplify a little bit. So we're gonna do 325 over square root of 4. Square root of 4 is 2, so it's x minus 5/2 plus minus, and 325 could be written as 25 going to that. 25 going to that give us 13. 25 times 13 is, and then it's 325. On the bottom, it becomes 2. And if you simplify further, x minus 5/2 2 plus minus 5 is equal to 13 by 2. And just add both sides of the equation by 5/2. So we get x equal to 5/2 plus minus 5 is equal to 13/2. So the final answer will be that. So x equal to 5/2 adding 5 radical 13/2. Second one will be 5/2 minus 5 radical 13/2. Okay, so that's a fraction answer, right? I'm pretty sure if you keep as a decimal, it should be okay. Let me see. You try earlier, it's okay. So if you already did it as a decimal number, so it'll be 6.25. I'm gonna put in both answers and then 81.25. It should be all good. The answer is good. Yeah, it's all good so far. And that's, yes, but still, right? They want a fraction, you see. So at the end, although we put in that, they still want to convert back to the fractions. So it's better, we stick with the fraction earlier. This now split the square root of plus minus 5 square root of 13 over 2. It's all good, right? And eventually it's going to be 5 over 2. Adding, you can either, I can't, then copy paste. You can just type it in 5, so 13 over 2. So that's the first answer, but at this one you can copy paste. If you feel like this is too much to type, and you can just change the sign between to minus. Copy and then just change the sign between. And check the answers. Then they are good, right? All of them are good. Okay, any question about this? Okay, this is very, very similar. I will skip this. Okay. Yeah, so this one is slightly different because the coefficient, right? The coefficient is not, it's not 1. So you gotta turn it into 1 first. So I'm gonna show you another. I'll show you one of the examples here. So if you have something like this, right, with the leading coefficient a is not 1, then usually the easiest way is to divide everything by 9. But every single one of these term by 9. And we cancel the 9. The x squared and 12, 9 can be reduced by 3. So over 3. There's 4 over 3x. And the last one, 3 over 9, reduce it, you get 1/3. 0 over 9, 0. So it's 1/3. And next step, we're going to do the divide this middle by 2, right? And then also you can just do multiply. If it is a fraction, you multiply by 5. 4 over 3 times 5. Divide by 2 is multiply by 5. Same thing. Yeah, from there you reduce it. So it's 4 over 6, reduce it, you get 2/3. And from here we square the 2/3. Get 4 over 9. So that's the, okay, so that's the third number we need. That's x squared minus 4 over 3x, adding 4 over 9. Now you're gonna subtract 4 over 9. And then minus 1/3, right? So add, right. That's it. And then the first 3 terms is a perfect square. Get an x minus 2/3 square. For those two, we're going to combine them. Minus 4 over 9, minus 1 over 3. LCD is 9. So you're going to multiply the second fraction by 3 here. Minus 4 over 9, minus 3 over 9. You combine them, you get minus 7 over 9. All right, so we get an x minus 2/3 square, and I move this to the other side, right? Where you add 7 over 9 from both sides of the equation. Cancel that. On the right hand side, I get 7 over 9. Now taking the square root, x minus 2/3 square equal to square root plus minus 7 over 9. And we get x minus 2/3 equal to plus minus square root of 7. Square root 9 becomes 3. And adding 2/3 from both sides of the equation. And so that x equal to 2/3 plus minus square root 7 over 3. Two answers, x equal to 2/3 plus square root 7 over 3. And then x equal to 2/3 minus square root 7 over 3. Okay. That's basically how you solve it. Any question? So this is for the 4 over 3. And then 1/3. So you're going to feed in all the numbers here. Set it up. Well, we can move the other, like 1 over 9. Go to the right hand side. Add a constant. The constant is going to be 4 over 9. And on the right hand side, it's removing 7 over 9. Then complete the square on this 2/3. Okay, then split the equation, square root square root 7 over 3. And eventually, you're going to do 2/3 plus square root 7 over 3. The other one, we can just copy paste, change the sign in the middle. Subtract it. Okay, that should do it. Check the answers. What? 1/9. 1/3. Yeah, my bad. It's supposed to be 1/3. Our load, yeah. Last part, oh yeah, I see. The square root actually just apply to the top, right? So this should be just square root of 7 by 3. For some reason, when I copy that, copy something different. Square root of 7 by 3. Okay, that should be good. Good. Square root only apply to 7. All right, now it's all good. So you try it. You guys try another one. Similar. Divide everything by 9 first. And go from there. All right, guys, let's take a half an hour break. So come back at 10:45.
Mister, I have a question.
Yeah, sure.
You already take the attendance because I came late. I was in doctor's chamber. I have an appointment. That's why.
Okay, I will take the attendance after the break. Right. So
Okay.
don't worry.
Okay.
I have to take
Okay.
the attendance here.
Yeah. Thank you. Thank you.
Sure, no problem. Talk to you guys in a bit, right? Okay. All right, let's resume, guys. So, let's go over the questions here, right? So first of all, we're going to divide every single term by 9. I got to divide every single one of them by 9, right? Let's skip any number. That's very important. First term becomes x squared, and the second term, if you reduce it, it becomes reduce 42 and 9 by 3, you get 14 over 3. It's 14 over 3x. And the third one, leave as is. Now, typically, it's easier if you subtract 38.9, 38 over 9 from both sides of the equation. Cancel that. So basically, we end up with x minus 14 over 3, x squared, x, and then equal to minus 38 over 9. Now, from here, you will divide, so half, first step 1, 14 over 3, divide by 2, it means multiply by half. Simplify, you get 7 over 3, right? Because 14 to reduce it becomes 7 over 3. And then we're going to square this number. 7 over 3 squared, 49 over 9. So that means we're going to add square minus 14 over 3x, adding 49 over 9. Same thing on the right hand side, right? Adding 49 over 9. Now, on the left hand side is a perfect square, so it's x minus 7 over 3 square. Right hand side, we combine them, 49 minus 38 is 11 over 9. Now from there, we take the square root on both sides of the equation, x minus 7 over 3 square equals square root plus minus 11 over 9. Now it becomes x minus 7 over 3 equal plus minus radical 11 over radical 9, that's 3. Now that's 7 over 3 on both sides of the equation equal to 703 plus minus radical 1103. Okay. Do you guys have any question about this? So two answers, 703 plus radical 1103. Okay. Yeah, so that will be 1403 here, 30 over 9. Now we can check every step along the way. Yeah. Let's check it. Okay, yeah, it's good. Now we can move on to the next step. It's minus 30 over 9. Add a constant. The constant is 49 over 9. Right on the right hand side becomes 11 over 9. Then we write a perfect square, so that will be 7 over 3 minus 7 over 3 parentheses square. And that will be square root of 11 by 3. And eventually we come out with two solutions. 7 over 3, adding 7 by 3, adding square root of 11, 3. And second answer, 7 over 3 minus radical 11 over 3. Okay, so that would be the correct answer for that question. Yeah, so that's pretty much everything in this section. So next up, we're going to take a look at the quadratic formulas, right? So I'm going to show you how people derive the quadratic formula from the scratch. Okay, so now, so basically all of this we practiced today. So far, it's going to be build a foundation for this quadratic formula. So I'm going to show you formula really quick. Section quadratic formula. I'm going to show you how mathematicians derive this formula, right? So x equal to, so let's say we get an f of x equal to ax squared bx and c. Quadratic formula look like this, right? So minus b plus minus square root b squared minus 4ac over 2a, right? That's basically the quadratic formula. Now I'm going to show you how people derive this quadratic formula here from the scratch. So basically start with the completing a square, right? So we complete a square. So we take out this, in order to solve for this, we set this whole thing equal to 0. So I'm gonna erase this. Now we setting f of x equal to 0. That means ax squared plus bx and c equals 0. But from here, we're just gonna we can subtract c, right? Both sides of the equation, just like what we did for the other questions. You cancel the c, we get ax squared plus bx equals c. Now, next step, factor out a. So we get x squared plus, when you factor out that, it becomes b over a x. Now we're gonna need to complete the square, right? So now let's see how we do that. So you're gonna do, first one is divide this by 2, right? B over a by 2 means multiply by half. We get b over 2a. Now second step, square this, so b over 2a squared. So basically we end up with a b squared over 4a squared. Now we're gonna add a b squared over 4a squared minus the same thing. Okay, now the first three terms, that's what we need, right? We're gonna keep it. I'm gonna change the color very quickly. Now we keep first three terms. That's a perfect square. They're gonna distribute this, move it outside, right? Move it to the right hand side. So it'll be a x squared plus b over ax, adding b squared over 4a squared. Once you distribute it, it becomes minus b squared over 4a. Because a times b squared over 4a squared, you can make a fraction. A go into a squared, cancel the cancel one of the a, right? So it becomes b squared over 4a equals c. Now next step, we're gonna add b squared over 4a both sides of the equation. Okay. Now we cancel that, right? And then combine those. When you combine those using the LCD, okay, so and then let me slow down a little bit. This pi is a perfect square. It's x plus this, right? B over 2a square. Right hand side c, make it c over 1 or plus b squared over 4a. Now the LCD is 4a. Okay. Now we're going to use 4a to combine them, right? So you multiply 4a here, multiply 4a here. So we get 4ac, a or 2 4ac over 4a, right? And then plus b squared over 4a. Then again, we're going to get rid of this. So combine them, we're going to turn into b squared plus 4ac over 4a. Now we're going to get rid of this a in front of this perfect square here, right? So you're going to multiply 1 over 8. 1 over 8. Okay. And a 1 over and a offset each other. Okay, so this cancel. Okay. So we end up with x plus b over 2a squared. Now simplify this becomes b squared minus 4a plus 4ac, right? Over 4a squared. Okay, almost there. Now we're taking the square root on both sides of the equation, right? Taking square root here on the left hand side. Right hand side put plus minus and then b squared plus 4ac. Should be minus 4ac though. Something is off. Let me double check. Plus b. That is subtract this. So we get this minus b squared plus 4ac. Oh yeah, minus c. I overlooked. You see, it's minus c here. It's minus c. So this is minus. So that should be minus, right? So I actually when I copy down the c, I overlooked. So so this should be minus right here. But that's a good practice to get to this. So it's minus 4ac. And that's why at the end it should be minus. This should be minus here. Should be minus 4ac. Minus 4ac b squared here. Okay, so and that's the top, right? And then over 40 squared. Now that's simplified, right? So it's x plus b over 2a or to plus minus square root of b squared minus 4ac. On top, on the bottom, square root of 4 is 2. Square root of a squared is 8. Okay. Then we get subtract b over 2a from both sides of the equation. Right, now we cancel that. If you put it together, x equal to now same denominator, right? 2a goes to the bottom. That's minus b plus minus radical b squared minus 4ac. And this is exactly where the quadratic formula comes from, right? By completing the square throughout this process. See, it's that same formula. So you can prove it by complete the square. Okay, do you guys have any question about this? Proof. This is kind of like proof, right? And most of the time you just have to apply the formula. That's all. Apply this formula to find the solutions. Any question about this? All right, so now let's take a look at how we apply those formulas to tackle some of the questions here. Apply the formula to solve for the x. Quadratic formula. Yes, let's look at some of the questions here. So most of the time, right, we handle this because it's not factorable. So I have to use the quadratic formula to figure out the solution here. I'm gonna show you one of this by using the standard form, and then also gonna check using the quadratic formula. So totally up to you, right? So you're gonna learn both way of solving this, just like how I prove it. So let's look at it really quickly, and I'll let you guys try it really quick later, right? When I finish. So step one, you subtract 4 from both sides of the equation. Okay, I'm gonna get x squared plus 6x equal negative. And like the other question, right? You're gonna take the 6 divided by 2. Step 1, you get 3. Now step 2, second step, square. That means that in order to complete the square, we're gonna add a 9, subtract 9 here, minus 4. Don't forget. I forget to copy the minus sign, right? It's very easy to forget. So be careful about this. So now this is 3 is perfect square, so we're gonna keep it there. And I get add 9 from both sides of the equation. Cancel that, you're gonna end up with x squared plus 6x by 9 for the 5. Now this is a perfect square, we get x plus 3 squared for the 5. Now from there, we just take the square root from both sides of the equation. Just like what we did from the section 6.1 practice, right? Very similar. But just do it step by step. So x plus 3 equal to plus minus radical 5. Now you subtract 3 from both sides of the equation. Cancel that. Now x equals to minus 3 plus minus radical 5. So that's a solution. Now let's look at how we apply the quadratic formula, right? Quadratic formula, we just need to identify a, b, and c. So now, first of all, the number in front of x squared, that's a is 1. B is 6, and then C is 4. So now apply the quadratic formula x equal to minus b plus minus radical b squared minus 4ac over 2a. Okay, now you're just throwing 3 numbers, right, into the formula. So that's going to be minus 6 plus minus b squared 30 will be 36, right? 6 squared 36 minus 4 times 1 times 4 over 2 times 1. So now it's minus 6 plus minus 36 minus 16 is 20 over 2. It's 4 times 4 is 16, and then 36 minus 16, that turned out to be 20. Now this 20 is radical 4 times radical 5, so that's the radical 20 equal to 4 times 5. And that's 2 radical 5, so minus 6 plus minus 2 radical 5 by 2. Now if you simplify, negative 6 by 3 is minus 3. And then cancel the 2, you get plus minus radical 5. Now you see, that would be the same solution here, right? But it's totally up to you. This one, it shows with the more details. But a quadratic formula usually is quicker, right? You basically get the answer very quick. Any question about this? Plus radical 5 and minus 3 minus radical 5. Okay, that should be good, right? Yeah. All right, I'll let you guys try one of these really quickly. This one, yeah, let's try previous one and show me another. Hey, yeah, you guys try this one. If you want to use both methods, feel free to do that. So you have both options open, just in case you forget the quadratic formula, right? And here A is 1, B is 4, C is 2. Quadratic formula x equal to minus b plus minus radical b squared minus 4ac over 2a. So give a shot, right? Let's go over this question really quickly. So if you apply the quadratic formula, just throwing the numbers into this, so we will get minus -50. So be careful about the sign. You just have to combine the sign afterwards, and then plus minus b squared, that would be -4 squared, and then minus 4 times 1 times 2. So sign is very important here. If you mess up with one sign here, then your result will be off. 2 negative turn to positive, 4 plus minus 16 minus 8 over 2. That's 4 plus minus radical A over 2. And this is 4 plus minus radical A is 4 times 2, so it's 2 radical 2. 2. And you divide into that, it's 2 plus minus radical 2. Okay. Any question about this? I will skip the other one, right? Because we did a lot of practice from first section. I think we good. And just practice quadratic formula in this section. 2 plus radical 2. That will do it. Okay, they're both good. Let's move on to next question. Next problem. Yeah, so it will get a little bit more complicated. You try this really quickly. So while you're doing this, I'm calling attendance. High tech. High tech is here, right? Okay, very good. And Abra. Abra here today. Yes, yes. I see your name. Okay. And Amaya, are you here? Yeah, Amaya's here. Michael is here.
Yes.
Yeah, okay, very good. And at the Mildred.
I'm here.
Okay, very good. And Nazareth. Nope, she's not here. And Daniel is here.
Yes, yes, Daniel's here.
Yeah, okay, very good. It says Simonia.
I'm here.
Yeah, okay. Very good. Peter.
I'm here.
Okay, very good. And Ivan,
Here.
10. Okay, here. Okay. And Con.
Yes, I'm here.
Okay, good. Yeah, Victoria. No, Victoria is not here today. Not here. And Li Shan.
Yes, I'm here.
Okay,
here.
very good. Yeah, thanks. Okay, and then Guang Yi.
Yes, I'm here.
Okay, very good. Okay, so I get everybody. Perfect. All right, so let's go back to this. I'll give you a couple more minutes. This one probably take a little while to get to the answer. Okay, let's go over the solution. One more time, A is 9. B is minus 24, right? Including all the sign. Very important. That is equals minus B plus minus B squared minus 4AC over 2. I'm throwing all the numbers into the quadratic formula. So minus 24 plus minus B squared, that would be minus 24 squared minus 4 times 9 times 5. Okay, and the bottom will be 2 times 9, 18, right? So simplify, we get 24 plus minus, and 24 squared is 576 minus, which is 36 times 5, that's going to be 180. Okay, and let's divide by 18. I'm just going to simplify further. Right? So 576 minus 180, that will be 693, right? 396. And we still gotta simplify a little bit more, right? On the radical part. So 24 plus minus, actually 9 go into this, right? So 9 times 44, right? 44, yeah. So that means 36 go into this. So it's better we use 36. So 36, this is actually 36 times 11. So it's 36 times 11 over 18. Now from here, we're just gonna simplify. Right? So we'll do 24 plus minus 6 radical 11 over 18. And it's not done yet, right? We still gotta simplify a bit more by reducing all the numbers by 6. So we get 4 plus minus radical 11 over 3. Okay, so that should be the answer. 4 plus minus. So we're gonna split it as 2 answers. Equal to 4 over 3 plus radical 11 over 3. First answer. Second answer, 4 over 3 minus radical 11 over 3. I think, any question about this? So let's put in the answer into the, okay, it's right here. Let's go back to this one. So, so first one is 4 over 3 plus radical 11 over 3. And the second one is 4 over 3 minus radical 11 over 3. Let me quickly double check to make sure the answer is good. Copy the right thing. Let's see this. Okay, let's go back, check the answer. Yeah, they were good, right? Okay. Now let's try a little bit more. Yeah, so this one, you got to deal with the complex numbers, right? So let's try one of them. So sometimes you may have a complex solutions. This is the one we have complex solutions. Let me show you how we tackle this type of problem. We did practice from section 6.1 with a little bit complex. Some of the questions have complex solutions. We do the same thing here, right? So use the quadratic formula, start with the A is 1, B is 4, C is 7. Now using the quadratic formula, x equal to minus b plus minus radical b squared minus 4ac over 2a. Right, and then how do we know that's a complex solution? Because b squared minus 4ac here is negative. This is the indication if this is less than 0, right? We're gonna have a complex solution. In this case, it will be 4 squared minus 4 times 1 times 7. 16 minus 28 is negative 12. That's definitely less than 0. Then we know complex solution. So minus 4 plus minus b squared minus 4ac, we did it, right? Minus 12 over 2a. 2a is 1. Let me just put back the 1. Easier this way. So it's minus 4 plus minus. Now this is 12. Negative 12 is 12 times negative 1. Negative 1 is I squared. So it's 12 times I squared over 2. Then we simplify 12, right? Square root 12 is square root 4 times 3. So it's 2 radical 3. So we get a minus 4 plus minus 2 radical 3. Square root of I squared is I over 2. Now divide into that, it becomes negative 4 by 2 is negative 2. And cancel the 2, you get plus minus radical 3i. So two solutions. First solution, x1 is minus 2 plus radical 3i. And then x2, the second solution, minus 2 minus radical 3. That's two solutions here. Any question about this? 2 plus radical 3i. multiply by I. And second one is -2 on each radical 3. And see that it does include all complex solutions. So you guys try another one, right? Let's see. Try this one. And let's go over the solution. So A again is 1, B is 10, B is 28. They're all positive. They're actually 2 minus B plus minus square root of B squared minus 4AC for 2A. Throwing all the numbers, so it's minus 10 plus minus B squared, that's 10 squared minus 4 times 1 times 28 over 2 times 1. So negative 10 plus minus 100 minus 112. And then over 2, right? Then we're going to simplify it. Negative 10 plus minus radical 12 And it's the same thing, right? Like what we did from the first question. So it's minus and plus minus. And 12 is 12 times -1. And then radical 12 is 2 radical 3, just like the other one, 5 over 2. And you're going to divide into that, you end up with minus 5 plus minus radical 3. So a couple solutions, x1, it's minus 5, adding radical 3, 5. X2 is minus 5, and minus radical 3. Yep, any question? Minus 5, adding radical 3. And second one is minus 5, subtracting radical 3 out. Okay, that should do it. Yep, it does. It's all right. Let's look at the next question. And they all very similar, right? I'll let you guys try this one. This one, the only thing is the leading coefficient is not 1. That's all. So we try this. All right, let's go over the solution. Here a equal to 9. B is -4, and then C is 11. Again, we have a formula minus b plus minus radical b squared minus 4ac over 2a. Now throw in all the numbers minus -12, and we turn into positive in second. B squared minus 12 squared minus 4 times 9 times 11 over 2 times 9, which is 18. So we have a 12 plus minus 144 minus 36 times 11, 396 over 18. So we simplified for plus minus 396 minus 144, that's going to be 252 minus negative 252. Yep. And over 18. Right, so now let's simplify further. So 252 will become, we're going to factor that, right? Let's see, what number go into that? We'll go into that. And 252 by 4, 63, 9, right? So 4 times 9, 36. It's 36 going into that. That's 7, right? So we're going to bring down 252 as 36 times 7. So this will be 252 times I squared. 252 is 36 times 7 times I squared. So this is 6 radical 7 over 18. Now if we simplify, reduce every single one of the number by 6, we end up with x equal to 2 plus minus radical 7i over 3. So get a couple solutions. X1 is 2 plus radical 7i over 3. X2 is 2 minus radical 7 over 3. So that should be the solution. Any question about this? So this time I'm going to try to put in as 2 plus radical 7i over 3. I'm going to put it as a fraction and see if that works. And the other one will be the opposite. Middle side will be the minus. See if this answer works. It does, actually. If you put it this way, it also works. That's fine. Okay, so now what if it's a fraction? So this is a typical one, which there's a fraction there. So you probably wouldn't just take it as is. Otherwise, it would be very, very complicated. So we're going to do a little bit transformation here before we apply the quadratic formula. Let me show you how to do that. So we need to get rid of all the fractions. So again, using the LCD, right? So look at LCD 6. So you're going to multiply every single term by 6. So multiply 6 across, right? Multiply 6 here, multiply 6, multiply 6, and 6, right? Across every single one of them. And once you do that, so this LCD is very, very important. Then we're going to simplify. So 2 going to 6 is 3 times, or you can do 18 by 2 is 9. So then add x squared minus 6x minus 1 equals 0. Now here we get a is 9, b is -6, and c is -1. So the quadratic formula minus b plus minus radical b squared minus 4ac over 2a. Now we go from there, right? So place A, B, and C with a given number, minus -6, plus minus B squared is -6 squared, minus 4 times 9 times 1 over 2 times 9. So this 6 plus minus 36 minus 36. Oh, this is good, right? So actually, this one is a special. So we end up with just one solution. So that means, no, this is minus. Oh yeah, I overlooked. It's not. C is minus, so this will be minus. So again, the sign. I forget to copy this negative sign here. This is very, very important. 36. The sign, if you miss any sign here, then your result will be totally off. So this is 36, adding 36, 72 over 18. And now 72 is 36 times 2. So this will be 6 plus minus 36 times 2, which is 6 radical 2 by 18. So once we simplify, right? So 6 plus minus 6 radical 2 by 18. When you simplify, we end up with x equal to 1 plus minus radical 2 over 3. So x1 is 1 plus radical 2 over 3. X2 is 1 minus radical 2 over 3. Okay, so that's pretty much, yeah. Any question about this? So the first one is 1 plus square root 2 over 3. And the other one is 1 minus square root 2. Yeah, they both good, right? So you try one of the similar questions right here. Give a shot. All right, let's go over the solution here. This question here, the LCD is 8. So 8, 2, 4, right? The LCD is 8. So you multiply every single term by 8. 8. And 0 by 8 as well. So cancel the 8, we get 9x squared. And then 8 times 3, that's 24 over 2, that's 12x. Out of this. And then 8 times 1 is 8 over 4, that's 2 equals 0. So now A is 9, B is 12, and C is -2. So use the quadratic formula is minus B plus minus radical B squared minus 4AC over 2A. Now we're throwing all the numbers. It's minus 12 plus minus B squared, that's 12 squared, is 4 times 9 times -2. It's -2 here. And then 2 times 9. We have the -12 plus minus the 44 plus 72 over 18. And you get -12 plus minus 216. 216 is the 36 times 6. Then we get -12 plus minus 36 times 6 over 18. So we have -12 plus minus 6 radical 6 over 18. And reduce each one of them by 6. And that will actually to -2 plus minus radical 6 over 3. Again, couple solutions. X1 is -2 plus radical 6 over 3. Or you can split out as 2 fractions either way you like. And then -2 minus radical 6. Solutions. Any question about this? 2 adding radical 6 over 3. And the -1 just change the sign in the middle. Yep, so we get 2 solutions. Both good, right? And if you turn in decimal, this is the equivalent decimal form, but we don't have to leave as is. This is the exact answer. That's what we want. Yes, cube, right? So we haven't dealt with any cube functions. So let's look at how we solve a cube function here. And yeah. So we already dealing with the square root a lot, right? A cubic root, like this question here, we just gotta solve for including all complex solutions. Okay. So that means we gotta do factoring, right? So turn into 2 cubed first. This becomes 2x cubed minus 3 cubed. Remember, a cubed minus b cubed equal to a minus b times a squared plus ab plus b squared. So we do the same thing. A is 2x, b is 3. So this factor as 2x minus 3. And then 2x squared. Yeah, I'm going to put in a square bracket. Minus and adding 2 times 2x and 3 second term. Third term will be 3 squared equals 0. I'm just going to simplify a little bit. 2x 3. This term becomes 4x squared. Adding 4 times 3, 12x. Adding 9. No, it's just AB, right? No 2 here. Oh, look, there's no 2. Just A times B. just 8 times 3. So 2x times 3 is going to be 6x. And equal 0. Okay. Now, we set it into, we set each factor equals 0, and then this is not factorable. So 2x minus 3 equals 0. The other two, we're going to use quadratic formula to solve this. So the first solution, adding 3 from both sides of the equation, we get 2x equals 3. And divide 2 from both sides of the equation, x equals 3 over 2. And second one, a is 4, b is 6, and c is 9. So we're going to use a quadratic formula. X equal to minus b plus minus radical b squared minus 4ac over 2a. I was throwing on the numbers, it's minus 6 plus minus b squared 6 squared minus 4 times 4, that's 9, over 2a, which is 2 times 4, which is 8. 2 times 4. Now I'm gonna continue here, right? So this minus 6 plus minus 36 minus 144, 16 times 944, 36 minus 142. That's negative 108, and the bottom is 8. It's negative 6 plus minus square root minus 108. So we're going to get two complex solutions here. So this is negative 6 plus minus 36 times 3 times I squared over 8. And this move up further, that will be minus 6 plus minus 6 radical 3 I over 8. And reduce it. Divide every single number by 2, minus 3 plus minus 3 radical 3i over 4. So 3 solutions, one real solution, 3 over 2, couple complex solution, minus 3 plus minus 3 radical I over 3. Okay, so list all the solution, including all complex solutions, 3 over 2 first. That's first solution. Now next one is a complex solution. Minus 3 plus 3 radical 3i. 3 radical 3i. And the third solution is change the sign in the middle. Minus. Okay. So that will be all 3 solutions. If you check it, it's all good. Right? Okay. Now you guys try another question. Take yeah, try this. And let's go over the solution. So again, we're just gonna compute, right? Difference of 2q, 2x cubed minus 5q. And again, will be 2x minus 5 times 2x squared plus 2 times 2x times no 2. Again, that's just 2x, a minus b. Again, 2x times 5 plus 5 squared. Now simplify, so we get 2x 5, this term is 4x squared, 2x times 5 is 10, adding 25 equals 0. 3 solutions. So this cube here indicates 3 solutions. However, two of them are complex solutions in this case. We will see that in a second, right? So we have one real solution set that equals 0, and 2 complex solutions. Here we get 5, we get 2x equal to 5, and x equal to 5 over 2. This is a real solution. Call this real solution. A couple complex solutions, 4 equal 10, c equal 25. By using the quadratic formula, minus b plus minus radical b squared minus 4ac over 2a. Now this is minus 10 plus minus 10 squared minus 4 times 4 times 25 over 2 times 4. Now that's simplified, so it's going to be minus 10 plus minus 10 squared is 100 minus, this is 4 times 100, 400 over 2, 8, that's 8. So this is negative 10 plus minus square root of minus 300 over 8. Minus 10 plus minus, that'll be 10 radical 3, 9 over 8. And from there, just simplify a little bit more, reduce every single number by 2. Minus 5 plus minus 5 radical 3, 9 over 4. So those two are the complex solutions and 2 complex solutions. You combine them, they have 2 complex. Which the total is 3 solutions. 1 real and couple complex solutions. Let's go back into the answers. Number 2, that's real solution. Then the complex solution. Minus 5. I'm adding 5 radical 3 I over 4. And we have another one, another complex solution. Is in between. And check the answers. Have 3 solutions here. Okay. Any question about this? Okay, that's how we use the quadratic formula, like to figure out second degree polynomial function, which is quadratic function, then this is a Q function, third degree polynomial function. And let's move on to section 6.3. Problem, yeah, 6.5. So we're going to take a look at problem and learn how to graph the problem here. Okay. So let's look at that. Okay. Parametric form. All right, so let's start with this question here. So let's quickly just complete the square on the right hand side, just like what we did for the other questions. On section 6.1. So we have two terms here, and we're gonna add a number. And the number is gonna be 3x. It's gonna be, you do a by 2, right? Like 4. Let's square that. 4 square, that's 16. So adding 16 minus 16. And then adding 19. So these two are the third number we're looking for is 16. And first three terms is a perfect square x minus 4 squared and adding 3. So we end up with x minus 4 and 3 squared. Any question about this? Check the answers. We get a correct answer. So you guys try another one. Let's go over the solution. So first one, we figure out the number. So 10 over 2. We get 5. And then square the 5. We get 25. So the 25 is what we're looking for. Add 25 minus 25. Adding 29. This is x squared minus 10x. Adding 25. Combine those two, you get f3. Those three are the perfect square looking for. And it's going to be x minus 5 squared adding 3. So minus 5 adding 3. Any question about this? Okay, let's look at next question. And let's try, right? Because first of all, I factor out the 2. Okay, then we go from there, show another something there. So you try it, and then we're going to go over solution in a second. Let's go over the solution. So first of all, factor out 2. We get x squared minus 4x. Leave some space here. We're going to take the 4 by 2. Get 2. And then after that, square it. Get 4. So F4. F4. And we're going to distribute it and move it outside. Get 2 times x squared minus 4x, adding 4. Adding 7 minus 8. When you distribute it, move it outside. And we get perfect square inside the parentheses. So x minus 2 squared, 2 squared, and minus 1. Okay. So the number in front of it is 2. 2 here and then and minus 1, right? Plus minus 1. So going back to this answer part, so you do 2 here, 2 minus 1. Yep, it's all good. Okay. So it's plus minus 1, it is minus 1. And then the vertex. Okay, so I'm going to quickly show you how to get a vertex. Just one second. Yep, let's try one of these. So again, the vertex is, in this case, open upward. So vertex is the minimum here. So going back here, because leading coefficient A is 1 greater than 0, so this parabola is going to be upward. We do have minimum. The vertex here is the minimum. Okay. So that's complete a square. So this is x squared plus 4x. We do 4 by 2. The 2 first. Substitute that. Square root of 2. You get 4. F4 minus 4 minus 5, right? And these two combine them. So you get perfect square inside parentheses. minus 9. This is perfect square, so x plus 2 squared minus 9. Then when x, so setting x plus 2 equals 0, that's axis of symmetry. Find axis of symmetry. Then minus 2 here, x equal to negative 2. So this is the x coordinate for the vertex. And once you plug in the negative 2 into that, you're going to find a y coordinate. So the y value equal to minus 2 plus 2 square minus 9. So 0 square minus 9 is minus 9. The y is negative. So the vertex will be x and y. So it's negative 2 and 9. And that's the lowest point for this problem. So the answer here is negative 2, negative 9. Putting the coordinate, x coordinate first and the y coordinate. Okay, and yeah, you try another one. Yeah, you try this one. This one, actually no calculation needed. Any suggestion? Will be the vertex here. Right, so here this is already a perfect square. So when x equals 0, then and that term becomes 0, then we get a minimum value here. The y value will be 0 squared minus 9, that will be negative. X coordinate 0, y coordinate 9. So the vertex will be 0, 9. Right? No need to complete the square because it's already a perfect square. So that's going to be 0, negative 9. And you can check the answer. Is correct. Let's look at the next question. Yeah, so this one, very similar, right? So you're just gonna factor out the 2 first. Go from there. I let you try this. Yeah, let's try this. Factor out the 5 first, and put the first 2 term in the first parentheses. Yeah, try this one really quickly. Okay, let's go over the solution here. So we keep the first two terms inside the parentheses. Move these outside, right? So now factor out the 5 x squared plus 6x. And let's find out that missing number, the required number to complete the square. So 6 over 2, 3. And square that number, 3 squared, that's 9. So you're gonna add 9. Keep the first three terms and then distribute this, move it outside. 5x squared plus 6x 9 minus 2 minus 45. This is a perfect square, x plus 3 squared minus 47. From here, the vertex setting x plus 3 equals 0 first, get x symmetry, so x equal to -3. And then from there, y value to be take this form 5 times -3 minus adding 3 squared minus 47. So the y value is equal to, this is 0 squared, so 0 times 5 is 0 minus 47. So the vertex is -3 minus 47. All right, any question about this? Okay, let's see. So they want us placing the vertex and x intercept. Okay, so I guess I'll go over this tomorrow, right? So so tomorrow we're going to review for the midterm exam. We're going to go over a couple of questions. Still have a couple more questions left in this section. Then from there we will review for the midterm exam. So back to this. Have 5 more questions from this section, and once we finish reviewing this and go over these questions, then we'll start reviewing for the midterm exam. And the midterm exam will be located in the website, right? So I'm going to show you where that is one more time. It's you're gonna log into the website tomorrow, and then we go from there. I'll show you the details tomorrow, right? But basically it's the same thing Professor Dawes showed you last week Tuesday. It's pretty much the same. Right? We just log in all the return reviews, and actual return is there. All right. Do you guys have any questions?
Yes. Do you know how many questions are gonna be in midterms?
How many questions? About, I think it's about 22, 24 questions.
Okay. Thank you.
22 to 24. I think probably around 22 questions.
So
Anybody
for the
else have a
midterm,
question?
for
Yes,
the midterm,
midterm.
is there gonna be like a trial midterm, like the finals where you have to do like 5% of this to access it?
I don't think so. We can take a look at that together. We just we still have 1 minute, you know. But don't worry, I will go over this step by step tomorrow. So you guys will not have a final exam. So you go here. Yeah, so click on that. No, right, just I sent you an email last time, so that's the email. Continue. I think there's no trial. Login really quickly. Password login. And then open the website. If you log in there, you should be able to see this couple review assignments. You see this part in midterm, a lockdown browser, midterm lockdown browser. But you don't have to. I think you can just 3 different parties in midterms with help and without help. Okay, so we're gonna go over maybe as many questions as possible tomorrow. And you guys can also try this on your own. Let's see, let's open it. Lockdown, password selected. Must achieve 5% higher, yes. Okay, so that's the 5% requirements here. You must achieve 5% password. Okay, let's see if we send us the password. I think the first they'll send out an email, right? With the password on it. Let me double check.
Excuse me, sir. I
Yes.
want to ask, during the test, can we go to the restroom or?
Yes, you can. You mean the midterm, right? Taking the midterm?
Oh, okay, thank you.
Yes, you can use the bathroom. If you have to use the bathroom, no problem. You can use that. McDonald use let me see. Sure. Yeah, no worry, guys. I'm just gonna end the class right now, and we're gonna talk about this in detail tomorrow, right? No worries. I'll go over all the details with you guys tomorrow. I said time's up, so let's just stop right here today. I'll talk to you guys tomorrow. Bye bye, guys.
Mister, I have a question.
Sure. Yeah. What's your question?
Mister, you know how can I get access for my BMC's email account because I don't have access for my account, like for my email.
Yeah. So what? So do you what do you need? You don't need to get access to the BNC email. You can use a personal email.
Yeah, I use my personal email, but I don't get any